Good morning. Good morning. Hi. Good morning. Hi. Good morning. Today, we will start the review. Last week, I leave 2 practice for you. Now, I just received Jinser's assignments. How about other students? Did you do it? If you have any question, you'd better to ask me. Okay, let's look at Jinser's assignment. Practice 1. Here, the table shows sales volume of one certain fraction 2013, 2014, 2015, and 2016. At a significant level of 0.05, please test. Is there a significant difference in the average value of sales in the last 4 years? So here, is there a significant difference in the average value of sales in the last 4 years? Average value of sales, it also means the mean of sales, right? In the last 4 years, so that means if there is different among these 4 years, then year is the factor. And here we have 4 levels. 1, 2, 3, 4, 4 levels, right? And here we have 10 cities. We record the 10 cities in 4 years, the sales. So, firstly, we will establish the data file, right? For the data file, think about here we have one variable is year. Second variable is city. Okay, and then the third variable is the sales volume. Okay, so look here. If year is 2013, city is 1, and then the value is 44, right? And then if the year is 2013 and the city is 2, the volume is 45. Okay, you record all these data. Here is the data file. Year, city, sales, and then because 2013, yes, we label it 1. 2014, label 2. 2015, label 3. 2016, label 4. Okay, then here, 2013, number 1 city, sales 44. Also, yes, please input 2013 year, the city from 1 to 10, the sales. The second year, city 1 to 10, sales. The third year and the fourth year. Okay, so totally we have 40 data. Okay, understand? Yes, it's very important for you to establish a correct data file. Then next, we'll analyze the first question. We'll solve the first question. The first question asks us if there are any difference in the last 4 years. Okay, so since the factor have 4 levels and the sales can be considered as normal distribution or close to normal distribution, then we can use one-way ANOVA. Okay. Use analyze here, compare means, one-way ANOVA, because the first question is very easy, okay? So here, dependent list. The dependent list is the sales here. The factor is year. And let's look at here, options here. Options, yeah, please select the homogeneity of various test. Brown, Foster, and Welch. Means, plot, and continue. Okay. Yeah, here is the method of the operation. Okay. Okay, and let's look at the Jinser's assignment. Descriptives. Good. It means in different year, the mean of the sales volume. Yeah, for example, 2014, 2015 is very close. 2016, it looks like a little bit more than other years, right? And also we can see that from 2013 to 2016, the means is grow. Okay. Here is the test of homogeneity of variance. Test of homogeneity of variance. This test is to will tell you if the variance of different years has difference or has no difference. Okay, so here is the first test. Because the variance is equal or the variance is not equal, well, you will look at different result. If the variance is equal, we will look at here. If the variance is not equal, we will look at this result. Yeah, anyone still remember? Okay. So let's look at the Jinser's answer. First question. According to the results of test of homogeneity of variance, the value of significant is 0.759, which is more than the significant level 0.05. Hence, the variance of group is equal. Yeah, here is right. Okay, but Jinser, here is it means the variance is equal. You didn't answer the question. If there is a significant difference in the average value of sales in the last 4 years, so you didn't answer this question. Here is the pre-test. Okay, so after you have this conclusion, then next you need to answer that the ANOVA, the one-way ANOVA, result of one-way ANOVA shows that the F value is, look here, combined, yes. F value is 4.375 and the corresponding significance is 0.01, which is less than 0.05. Hence, the average value is different. Okay, so you next you need to analyze like this and draw conclusions in the last 4 years. Okay, so here is the first question. Second, let's look at the second question here. Is there a linear trend existing in year and sales? So that means you need to answer if the sales volume increasing proportionally when the year from 2013 to 2016. Okay. Let's look at the here. If the volume and the linear has the linear, if the sales volume and the year has the linear relationship, then firstly, the factor year should has significant impact on sales. Okay, that's very important. So that means the one-way ANOVA should be significant. Based on the one-way ANOVA significant, then we will test if the year and the sales has the linear relationship. Okay, so next, still we will use compare means, one-way ANOVA. This time we will select the contrast. Yeah, contrast, select the polynomial, right? Degree, linear, it will test linear. So most of the time we would like to use quadratic, because when you choose quadratic, the computer will test linear and quadratic together. Continue. Okay. Yeah. So this time let's look at the results here. Okay, from here, we can see that the linear term contrast. Okay, so this row, the F value is 12.724, and the corresponding significance is 0.001, which is less than 0.01. Okay, so that means it's very significant. The year and the sales volume. Look here, it shows the linear trend is very significant. Okay, so let's look at the Jinser's answer here. Jinser, yes, good. It has linear term. Okay, the F ratio is 12.724, and this value is very significant at 0.001. No. Here, Jinser, you need to, it's not 0.001 level, but 0.01. Why? Because the significance is more than 0.001. Okay, here's more than 0.001. So here you should write the significance at 0.01 level. That's good. That's correct. But at 0.001 level, it's not significant because the significance is 0.001. Other data. Okay. Okay, so here, the significance, the corresponding significance is but in fact, this sentence is useless. Okay, you don't need to write this. Why? Because this value is significant at a 0.01 level. If this value is significant at a 0.01 level, then the significance is absolutely less than 0.05. Significant at a 0.01 level means the corresponding significance is less than 0.01. Then it is equal to, this value is significant at a 0.01 level. Okay, so this is not necessary to write it again. Hence, the linear trend is very significant. Okay, so this question, yes, Jinser, you answer. The answer of your question is correct. Very good. This answer for the question 1 is not enough. You need to have further analysis about this result. Okay. Okay. Good. Okay. Yes. Anyone have question? Yeah, do you understand? Okay, let's start the question 2. Here, the practice 2, the teacher used 3 different teaching methods because they want to know if there are any different effects on the students' knowledge when they use different teaching methods. Okay. So here, the teaching methods, the data 1. 1 means punish. Okay. And the 2 indicates indifferent. Neither punish nor reward the students' effort. 3, data 3 indicates reward. Okay. And after the teacher used 3 different teaching methods after 1 semester, yeah, they will give the students the test and the score of the test to measure the students' knowledge. Okay, so here the dependent variable is the students' example marks. And here, based on theories of upright conditioning, we expect punishment to be very unsuccessful way of reinforcing learning. We expect reward to be very successful. Okay, so that means based on the theory. So we think. Therefore, one prediction is that reward will produce the best learning. Second is that the punishment will be worse than indifferent approach to learning. Okay, so here we will use the practice 2. So this time, when you compare means, you need to use the contrast. Okay. Yes, please use the planned comparison. The planned comparison. The first hypothesis is reward results in better exam desires than either punishment or indifference. Okay, reward results in better. So here is in better. Okay, either punishment or indifference. So for the planned comparison, okay, because here you need to use the planned comparison, and also the reward, punishment, indifference. So here reward is one group. Punishment and indifference is another group. So we will compare reward, punishment, indifference. Reward, if you use the coefficient 1 for reward, then the punishment and the indifference is minus 0.5, minus 0.5. Or reward, you can use 2 coefficients. And then the punishment will be minus 1, indifference minus 1. Okay, so it's very important for you to know who is the reward. Okay, and here, yes, look at here. Punishment 1, indifference 2, reward is 3. Okay, so let's look at the practice 2 here. Dependent list is the example exam mark. Exam mark is the dependent variable. Factor is the type of teaching method. Okay, and before we use the contrasts, firstly, still you need to first the homogeneity of variance test, the BF, the Welt, the means plot. Yeah, that's the first step, okay? Okay, let's look at here. The test of homogeneity of variance shows the Level statistic is 2.569. Okay, and the significance is 0.095, which is more than 0.05. Hence, the variance of different group can be considered equal. So that means the equal variance is assumed, right? If the equal variance is assumed, then we can look at the ANOVA, the result here. Here, the F value is 21.008. The corresponding significance is less than 0.001. So that means the different teaching method result in different example mark. Okay. This is the first step. Then next, we will use the contrast. The contrast here, we will use the planned comparison, right? Planned comparison, we will add the coefficients for different teaching method. And we know one is the punishment, 2 is indifferent. So here 1 is punishment minus 1. 2, the second variable, the second level is the indifference. So here is also minus 1. The third is the reward, it's 2. Okay, because punishment add indifference, the coefficient is minus 2. Reward, the coefficient is 2. So all the coefficients, when they added up, it should be 0. Okay, so this rule you should follow. Continue. Here, look, punish minus 1, indifferent minus 1, reward 2. Okay, so let's look at Ginser's. And the contrast tests, the t-value, because the variance is equal, so we will look at the assume equal variance here. The t-value is 5.978. A significance is less than 0.001. So it's significance at a 0.001 level, right? Okay, so that means the reward is better than either punish or indifferent. Okay, let's look at Ginser's answer. Okay, Ginser, the first is correct. But the contrast coefficient, here is not correct. Why? Because punish is minus 2, indifferent 1, reward 1. Then you are testing other hypotheses. If the coefficients like Ginser's, then it should be like punishment has lower effect than either indifferent or reward. Okay, then the hypothesis should be like this: punishment is one group, indifferent and reward is one group. So I think maybe yes, you made a mistake. You think the number 1 is reward, but in fact it's punish. Okay, so Ginser should take care. Okay, and then the second hypothesis. Let's look at the second hypothesis. Indifference will lead to significant better exam results than punishment. Because here you need to use planned comparison, right? And here indifference better than punishment. So here indifference is one group, punishment is another group, and the reward not attended in comparison. So reward, the coefficient of reward will be 0. Indifference, better. So indifference is 1. Punishment minus 1. Okay, because the level 1 is punishment, then punishment is minus 1. Indifference is level 2, Then indifference is the coefficient is 1. And reward is level 3. So reward here is 0. Minus 1, 1, 0. Okay. So let's look at here. Okay, so we can click next. Okay, for the punishment, minus 1. For indifferent, 1. For reward, 0. Okay, so you should have these values in your mind. Okay, 1 is punishment, 2 is indifferent, 3 is reward. So you should always have the values in your mind. Then here I add the minus 1 for punishment, 1 for indifferent, 0 for reward. Continue. Okay, let's look at here. Minus 1, 1, 0. Then here is contrast 1, right? We already analyzed it. And this is the second hypothesis. Here the t-value is 2.505. The corresponding significance is, be careful here. Here, things is better or worse. Then here you should use the one-side significant. Okay. Also, the first test also should use the one-tailed. Okay, because here is less than 0.0001, so we didn't divide by 2. But here, 0.019 divided by 2 is 0.0095, okay, which is less than 0.01. Okay, so here should be very careful. Okay, so that means for all the contrast, the planned comparison, you need to use one-tailed significant. And the one-tailed significant is the two-tailed significance divided by 2. So for this hypothesis, the significance is 0.0095. Okay, so that means the teaching method of indifferent has better effect than punish. Okay, then so there, yes, I think the Jinser has the wrong coefficient, but the method is correct. Okay, the method is correct. That's very good. Okay, if I didn't tell you to use the planned comparison, if I just ask you these two questions, then Jinso, yes, you are right. You can use the multiple comparison. Yeah, if the reward resides in better exam, because from the multiple comparison, you can see that reward results in better exam results than either punishment or indifference. Yes, that's right. That's right. Okay. Okay, good. Yes, and also second, you use one-tailed unit test. That's good. Quite good. Okay. Yeah, now we completed the assignments for last week.